Hi, my name's Abe and I'm going to be showing you how to use the chain rule today. So, you may have seen that the formula for the chain rule is this. It goes dy dx is equal to dy du du dx. And just so that you're sure you're in the right class, the chain rule is used to find a derivative of a function. So what is it really saying? You know, what's going on with this? All this dy du du dx. Anyway, this is what it's saying. It says, if you get some function, right, y equals something something, let's say, for instance, y equals 4x cubed minus x to the power of 7. Let's say you want to differentiate that. You go, whoa, okay, it's got like stuff going on, you know, it's 4x cubed minus x and then all to the power of 7. What's going to happen? It says this. The chain rule says, well, if you can find dy dx straight up, good for you, go for it. But if not, you can actually take a chunk of y and call it u, and then you differentiate two functions, hopefully two simpler functions, and then you put them together. I'll show you how this works. I'm going to show you how this works with our little example. So we've established that for our little example, you can't really just differentiate that straight up. Pretty tough, pretty tough. So I'm going to pick a chunk of u, and I'm going to say, a chunk of y, sorry. I'm going to say that the chunk I'm going to pick is this bit here, 4x cubed minus x. I'm going to call that u. Okay? So this is what's going to happen. You say that u equals 4x cubed minus x. And what does y equal? Y doesn't change. Y doesn't change. But instead of expressing y as a function of x, you can express y as a function of u. So you just go, y is u to the power of 7, right? Where u is 4 times x cubed minus x. Okay, cool. And so look back at the formula. What you need is dy du. Now, what's going on with dy du? It means differentiate y with respect to u. So you need y as a function of u to do that. Oh, look what we have. Right here. Y as a function of u. Really good, right? And then you also need du dx. Du dx means the derivative of u with respect to x. So you need u as a function of x. Oh, look. U as a function of x. Right there. Aren't we organized? This is excellent. So yeah. I'm doing lots of strokes. So yeah, we've got what we need. So all you need to do is go ahead and write dy du. Now you're differentiating u to the power of 7. What do? You bring down the power, and then you take 1 away from the power. 7 times u to the power of 6. Easy. Du dx. It's pretty simple for you as well, right? Bring down the power. 3 times 4 is 12. Take 1 away from the power. X, differentiate x, you get 1. Okay, what does the rule tell us to do? It says that dy dx is equal to dy du du dx, right? So let's just throw those in. Dy du is 7 times u to the power of 6 times du dx. Du dx is 12 x squared minus 1. Now you can't leave your answer like that because you're looking for dy dx, derivative of y with respect to x. So x should be your only variable inside, like no u's. So what do you do to get rid of this u? You convert your u into x's. You can say, oh, u equals 4x cubed minus x, right here, right? U equals 4x squared, or 4x cubed minus x. So we can call this, whoops, wrong color, 7. Now u is 4x cubed minus x to the power of 6 times 12 x squared minus 1. And that can be our final answer. Do you see how all that happened? Not very hard. In fact, once you pick u, the rest of it is super mechanical. So, the million-dollar question. Million-dollar question. How to pick u? That's really what you want to know. Now, there's no straight up easy answer, but I can give you some examples and we can pick u, and I can go through what goes through my mind as we go through this. Does that sound like a good idea? Yes, it does. So let's just try some different functions, right? So y equals e to the power of cos x. Not too hard, right? Because x has had two things applied to it. You applied cos, and then you applied the exponential. So in this case, it's fairly simple to see that u is probably going to be cos x. And if you let u equal cos x, then y equals e to the u. Both of these are pretty simple to differentiate. You'd agree with me. Okay, so that's a simple example. What about y equals cos the log base e of x? Again, similar kind of case, right? Two things have been applied to x. You logged it and you cos it. You can say, well, u can equal log x, which would leave y equals cos u. Again, simple to do. Simple to do. Okay, something a little bit harder then. How about y equals 2 sine cubed 2x minus sine squared 2x plus 4 sine 2x. Now, the problem is that x appears in multiple spots. But you'll see that what's common to every term is sine 2x. So in this case, if you were to let u equal sine 2x, you'd get rid of all the x's, and you'd probably have a decent looking function to come out of it. So if you let this happen, you'd be like, okay, well, u equals sine 2x, y equals, so you just go ahead and replace sine 2x with u. So you'll get 2u cubed, right? Because u is sine 2x, minus u squared plus 4u. Again, u and y are both functions you can differentiate. So the idea here is that you break it up, not break it up, but you split it so that u and y are both easily differentiable. Give you another one. What if I have something that looks like this? Y equals 3 e to the power of x minus 1 2x plus 7. Ooh, looks different, doesn't it? For one, there's no simple sort of x function, and also you can't. It's not like the previous one where it's just all sort of split up and you can sort of pick. Here, actually, a little bit of work needs to be done. What you can do is expand the power on the e, and that's what we're going to do. So you can do 3 e to the, now let's expand this thing, so you'll get 2x squared minus 2x plus 7x minus 7. That's just 3 e to the 2x squared plus 5x minus 7. Does that look a little bit better? It does, doesn't it? Because here, obviously you can do u equals 2x squared plus 5x minus 7. And what does y equal? Y will just equal 3e to the power of u. So yeah, sometimes you may need to do a little bit of work for your u and y to pop out. Again, note that in this case, u and y are both fairly easily differentiated. One last little thing. What if I have y equals 2e to the 3x minus e to the 2x plus 4e to the x? What does this look like? This one looks just a little bit like, which one? This one, doesn't it? So you could go ahead, you could go, well, u equals, how about e to the x? Then y would equal 2u cubed minus u squared plus 4u. Yeah, they're both differentiable. Pretty good. But actually, that's a really, really dumb idea. Tell you why. Because you could just differentiate this thing straight up. You know how to differentiate e to the 3x, e to the 2x, and e to the x. So yeah, don't think that just because you can use the chain rule, that it'll actually help you. You have to decide that the chain rule will actually help you before you use it. And so, just as a quick example, and just to finish off, what I'm going to do is I'm just going to finish my question here. So this question. This last part with 3e to the power of x minus 1, 2x plus 7. So the rest of it is fairly mechanical, but I think it's still nice to finish. So I'll just draw a little line here so we know what question we're doing. There we go. So yeah, blocking out this little bit just for our space. So yeah, if u equals 2x squared plus 5x minus 7 and y equals that, remember that dy dx is dy du du dx, right? I can see I'm going to be short on space. Okay, du dx is simply, well, 2x squared becomes 4x, 5x becomes 5, 7 is nothing. Easy. dy du, well, 3e to the u becomes 3e to the u, because e to the u doesn't change, right? And so dy dx is going to equal dy du, which is 3e to the u, times du dx, 4x plus 5. There we go. Not finished yet. Remember, you can't have u's in your final answer. So subbing u back, you get 3 e to the, now what was u originally? 2x squared plus 5x minus 7 times, I'm sorry, I'm going to go over the next page, times 4x plus 5. And that's our final answer. So yeah, there's the chain rule. I've given you a few examples on how to pick u, which I've said is the key to this whole exercise. And remember that it's just a rule, right? Once you've picked u, the rest of it is mechanical. Very, very easy. So I hope you've enjoyed yourself, and I will see you next time.